In this video, I'm going to be talking about rational functions, specifically finding their horizontal asymptotes. Now remember, a rational function f of x can be written as a polynomial p of x divided by a polynomial q of x. And the existence of horizontal asymptotes depends on the degree of the polynomial in the numerator and the degree of the polynomial in the denominator. So if the degree of the numerator is less than the degree of the denominator, then there is a horizontal asymptote, and it will always have the equation y equals 0. But if the degree of the numerator equals the degree of the denominator, then there again is a horizontal asymptote, but its equation is y equals a sub n divided by b sub m, where a sub n and b sub m are the leading coefficients of the numerator and the denominator respectively. In fact, this fraction here is called the ratio of the leading coefficients. And finally, we have the case if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So looking at our examples, in the first case, f of x equals 3x plus 4 divided by 9 minus 5x. What is the degree of the polynomial in the numerator? What's the highest exponent on any of the x's? It's a 1. So the degree of the polynomial in the numerator is 1. And how about in the denominator? The highest exponent again is a 1. So its degree equals 1. So in this case, the degree of the numerator equals the degree of the denominator. So it's the second case. So there is a horizontal asymptote, and the equation is y equals the ratio of the leading coefficients. Now remember, the leading coefficient is not the coefficient of the first term of the polynomial. It's the coefficient of the term that has the largest exponent. Well, in the numerator, that happens to be our first term. So what is the coefficient of the x term? It's a 3. And now in the denominator, the leading coefficient is not the first term because the second term has the x with the highest exponent. So its coefficient is -5. Now, we never leave a negative in the denominator, so the equation of the horizontal asymptote is y equals -3/5. In the second example, the rational function f of x equals 7x plus 2, all divided by the quantity 2x squared plus 5x minus 12. Well, looking at the numerator, what is the highest exponent on any of the x's in the numerator? It is a 1, so the degree is 1. And for the denominator, what's the highest exponent on any of the x's in the denominator? It's a 2, so the degree is 2. So in this case, we know the degree of the numerator is less than the degree of the denominator, since 1 is less than 2. So this is the first case. So there is a horizontal asymptote, and it has the equation y equals 0. And now looking at our last example, f of x equals x squared plus 2x plus 9, all divided by 3x minus 11. The degree of the polynomial in the numerator, the highest exponent in the numerator, is a 2. In the denominator, what's the degree? The highest exponent on any of the x's is a 1. So in this case, I know that the degree of the numerator is greater than the degree of the denominator, as 2 is bigger than 1. So that's the third case here, and that means there is no horizontal asymptote. And in this case, the degree of the numerator is 1 more than the degree of the denominator, and this example will have a slant or oblique asymptote, but that is the topic for another video.